I would like to introduce you to Richard Feldman, who is our first speaker and the creator of the Rock programming language. Hi, Richard.
Thanks for having me.
So, Richard, what can you tell us? Like, introduce yourself briefly, although most people already know you, but still.
Yeah, I'm Richard. I made the Rock programming language. Previously, I'd done a bunch of stuff in the Elm programming language. I wrote a book about it for Manning called Elm in Action. And then before that, I've done all sorts of different languages and projects and stuff like that. I'm relatively new to low-level development and percentage-wise in my career, maybe like the past 5 years-ish. And mostly I got into that because of Rock. And actually, shout out to Andrew Kelly, who's in the back. He was like an influential person early on in like Rock's development because I ran into him at a conference and we started talking about stuff. And he's been a great person to talk to. We ended up actually making Rock standard library in Zig, and it's been a wild ride. But I'm excited to be here and excited to talk about some of the stuff you were just talking about.
Awesome. So, second question: have you eaten anything interesting while you're here?
Yes. So yesterday I had actually you recommended this. This was the Milanese totally blanking out risotto. Yeah, it's like totally yellow, like really tasty. I didn't actually know that Milan had its own risotto, but now I know, and it's in my belly. Actually, not anymore. It's probably digested by now, but you know.
Okay, so I'm fiddling with a tablet because I have one last question for you, which is a question about your talk. So I mentioned that there's going to be Twitch chat active while you give your talk, and you're also going to have an iPad next to your speaker podium so that you will be able to see chat while you give your talk. But you have the option of choosing. Do you want normal chat or do you want emote-only chat?
Let's do normal, although I'm probably not going to check it until like the end of the talk.
Okay, sounds good. So thank you very much. Please give it up for Richard.
Hey, what you guys got?
Yeah, no, this one I think. Yeah, so this is very. That's what I mean by about.
It's all good. How can I slide this out non-awkwardly?
I can unplug it here so you can pull it.
There we go. That'll be less on. I don't know about non-awkward. Less on.
Come on. Just two grown men who know each other and another compass.
Cool. Okay. All right. Hello, everyone. This is Hybrid Level Programming. I'm Richard Feldman. So, as I talked about with Loris, I've made this programming language, Rock. We have a website at rocklang.org. And when doing development on this website, like actually building the website part of it, I wanted, of course, a static HTTP server. So the basic idea is I run the build, spits out all the HTML, and then I can load that up in the browser. Now, I was seeing some really strange download times with the static HTTP server that I was using. Now, remember, this is serving local files off my machine. There's no network involved here. This is the graph that I was seeing, and let me just highlight two things that might seem kind of weird. Two of these downloads are taking 5 seconds. Now, this is just serving local files off of my machine. What is going on with that? I'd hit refresh, and I'd just be sitting there watching the spinner like, what, is there a network involved here or something? Like, no. And also, so I had 3 font downloads, one of which was the 5 seconds one. The first one, font downloads and some JavaScript downloads. So the first font download was 30K font, that took 2 milliseconds. Second was another 30K font, took 4 milliseconds. That's like, whatever, probably margin of error. And then the other was 10K, and that took 5 seconds. What? The JavaScript downloads, he had 13K, and then another 13K, 1 millisecond, 2 millisecond. And then the last one, 18K. Okay, fine, that's a little bit bigger, but 5 seconds. So what is going on here? I'm not delighted. This is not like the user experience that I would want from my static HTTP server. This is not software I can love. Now, we're going to do a little bit of audience participation here. And guess, just based on only telling you the following facts about the static HTTP server, I ended up trying 3 of them, and they had different characteristics. Let's see if you can guess which one was the slow one. I've numbered these, so if you're in the chat on the live stream, you can just put in the number that's your guess, and then also if you're in the room, I'll show you all 3, and then we'll do a raise your hands for which ones. All right, so here they are. So one of these was one file, 150 lines of code, no dependencies. Another one had 14 dependencies. Another one had 87 dependencies. All right, so just show of hands, how many people think the slow one was the one that was the one file? Okay, there's 2, 3 hands. All right. How about the one with 14 dependencies? How many people think that was the slowest one? Okay, like 2, and out of 87 dependencies. Okay, that's like all the rest of the hands. All right, and maybe we'll see some numbers in chat as well. Okay, now, second thing I want to ask you about is which one of these 3 languages do you think was the one that had 87 dependencies, so the most dependencies? I'm going to give you 3 languages and see if you can guess which one was the one that had 87. C, Rust, and Node.js. How many people think the C one was the one that had 87 dependencies? All right, that's 0 hands. Whoops. Rust. Okay, actually, all right, maybe a third of the hands, and then Node.js. Okay, and there's the rest of the hands. All right, cool. Okay, so let's go over the answers to this. So the C one was the one with 1 file, 150 lines of code, no dependencies, everything loaded instantly. The second one was Rust with 87 dependencies. That was the slow one. Yeah, so if you guessed those 2 things, congratulations. You win satisfaction. And then Node.js was actually the one with 14 dependencies. So this is not what I would have guessed. If I were in the audience, I would have guessed that Node.js would be the one with the most dependencies and also the slowest, because I think of Rust as oh, that's like a low-level language. That's it's got to be fast. You rewrite it in Rust, so it becomes fast. But no, Rust was the one where I was seeing the 5-second downloads, and actually, when I switched from a Rust one to a Node.js one, it was instant. And I was like, what's going on here? What's the deal? Like John Travolta playing Pulp Fiction, you know? Okay, so where did this slowness come from? If it's not, the language, it's something is going on here. Well, so here's the C implementation, which I actually, I had to happen to have this kicking around because I'm going to do a C course for front-end masters, and in the course, it's like a 1-day workshop, and you build up to, audience starts off not knowing any C, and then at the end, they build a little simple HTTP server, it's a storing static file. So I already had this implementation lying around, 150 lines of C, and 2 of those lines are, one of them is a write to the TCP socket with the header so far. So basically an HTTP server, there's kind of 2 basic things you need to do when you're sending static files. So one is you write the header that says 200, okay. And then the second is you do send file, where you've got this file that you've already opened from the disk, and send file is essentially a syscall that just says, hey, just take this open file descriptor, just send whatever's in there directly to the socket. So we're talking about 2 syscalls here. Syscalls, if you're not familiar, these are basically just the lowest level operating system primitives you can get. You just directly tell the operating system, hey, I want you to do this thing. There's no wrapper around this. There's no any overhead here. There's really no lower level you can get to in user space in the operating system. And these are user space programs. So the only way you can get lower level than this is if you're doing kernel stuff or something like that. So for the purposes of this user space application, this is the lowest level I can possibly get to. So in the C implementation, I'm not where could the problem be? I'm well, this is it. Where else could it possibly be? There's these 2 syscalls that I'm doing. There's no possible way that it could be slower. So if the C implementation had been slow, I wouldn't have a lot of places to look to try to figure out where those 5-second weird outlier download times are coming from. Here's the Rust implementation. I'm going to show you 2 lines from it. One is called function handle. So if you're not familiar with Rust, don't worry about the self part. Basically, it's taking a request, and the request is going to be some sort of struct that has information about the request that's already been parsed at this point. And then it returns something called an iron result, and then that's a wrapper around the response. What is an iron result? So I looked into the this dependency that this Rust static HTTP server has, and there's this crate, this package called Iron, and Iron describes itself as a high-level web framework built on Hyper. What is Hyper? Okay, so this part of the 87 dependencies in this Rust project, you got the application at the top, and then underneath the application, you have this Iron framework, which describes itself as a high-level framework, and then Iron's built on Hyper, which is doing the HTTP stuff, and then that, of course, is built on the Rust standard library, and then all the way down at the bottom, you got the operating system. Now, meanwhile, in server.c, we have the application, and then the syscalls. There's just nothing in between. So this is a pretty big difference if I'm trying to figure out, why is this thing slow? I mean, there's a lot of code in the middle here, in this other stack here. The problem could be anywhere in here. It could be in the application, but it could also be in somewhere in Iron. It could be somewhere in Hyper. It could be somewhere in the Rust standard library, or it could be in some interaction between any of these. So there's just a lot more potential surface area for slowness to creep into the system. If I were trying to debug this thing, I didn't go that far for this talk. I didn't try to actually figure out what the bug was, but it's just going to be a lot more work than the version that's just cutting out all those other layers and just doing a couple of syscalls directly. Now, a reasonable question you might ask is like, why wasn't the Node.js server slow? Because, I mean, it's also got a bunch of layers. Like there's the Node.js standard library, there's a JS interpreter, V8, there's the C standard library on top of or below all that, and the operating system's like below all that. There's still a whole bunch of layers there, and yet it wasn't slow. And also on top of that, you might notice like these things are definitely a lot bigger of dependencies of layers than the Rust ones were. I mean, really, if I were to sort of expand them out and maybe make them a little bit more to scale, like the C standard library, not really adding a whole lot of code, a whole lot of overhead compared to something like an entire JIT JavaScript interpreter of V8 or the Node.js standard library, you would think, given the sort of the size of these layers, that the Node.js one would be slower. But the thing is that although these layers can sort of create a performance ceiling where you're like, well, you can't really get faster than this because like the minimum amount of overhead you're dealing with on every single request is going through all of this, that can limit an app's potential speed, but it doesn't necessarily mean that that's going to be noticeable. And this is something that personally, as someone who likes getting lower level now and likes to sort of get under the hood and do things like this, it's kind of hard for me to grapple with, to be honest, because I'm like, I want to make things as fast as possible because it's fun. But oftentimes I have to be honest with myself and say, yeah, maybe nobody's going to notice in this case. I mean, at the end of the day, the thing that matters is like the end user experience. And for me, the end user experience in this case was actually best with the Node.js version and the C version. And I couldn't really tell a difference between the two. Like if I just go and hit refresh on both of them, it feels like the page loads instantly, even though I know that under the hood, there's all of this extra stuff happening in the Node.js version. So although this could have caused a problem, in practice, in this particular case, it happened to not cause one. Okay, so I'm trying to answer the question. Let's say I'm like debugging, this Rust one. Where is the code that's causing this? And, in the C version, it's like probably going to be one of these two things. Now, worth noting, it is theoretically possible that there could be 5 seconds of latency introduced somewhere other than the 2 I/O operations in here, but I kind of doubt it. I mean, it seems really unlikely you'd have to have some like absolutely enormous for loop that's just doing a bunch of calculations. I don't even know how you would possibly make that much latency any other way. But I'm guessing like probably what's going on is some interaction between it's trying to do some really fancy multi-threading thing, and there's like back pressure and queues and channels and stuff like that. And somewhere in all that complexity, which is totally unnecessary for this particular use case, something is blocking on something else that shouldn't be or something like that. And it's leading to some pathological case where some of these things, which are very small downloads, are ending up being way longer than they have any business being, even though the same web server was serving things like files of the same size with no problem in a couple milliseconds, and then sometimes it's 5 seconds. The point is that all of these layers are going to make it a lot harder to figure out where the problem is, and therefore to solve the problem and make a more delightful user experience. So the point here is that going lower level does not guarantee going fast. You cannot just say, let's take this Node.js thing and I'm going to rewrite it in whatever Rust I want and it's going to be faster. It doesn't automatically follow. It's more that if you go lower level, you do guarantee fewer potential sources of slowness. Like there's less potential places that slowness could get introduced. Well, you still can't introduce slowness. It's not like it's a panacea. It's not like, you still have to sort of know what's going on and be able to write good software, even though you're, not dealing with all those layers. Now, so the Rock programming language has a little bit of a different approach to this, and it's something that, as far as we know, is sort of unique. So I'm not going to get too much in depth on how Rock does things, but at the top of the stack, of course, you have the application, and then we have this concept of a thing called a platform. So a platform in Rock is basically every single Rock program is 2 pieces. It's an application, which is sort of the thing that you're building, and then the platform is usually a sort of domain-specific foundation. So we talked earlier about this like iron thing. It's like, I'm a high-level language framework for doing web servers. You could do the same kind of thing in Rock as a platform and say like, this is a platform for making web servers. Now, underneath that platform, there might be other stuff, like maybe there's the host implementation. So the difference between a Rock platform and like something in Rust is that usually underneath the platform, there's what's called the host that's written in a non-Rock language, a different language, usually a lower level language. And then beneath that, there might be a host standard library. So for example, if I've got a Zig platform, I might have some Zig code that's specific to my web server use case. And then also underneath that, there's the Zig standard library and then the operating system below that. But the thing is, there's nothing innate to a Rock platform that requires that many layers. You don't have to do it that way. You can, but you don't have to. So for example, you might say, I'm not even going to use the host standard library. I'm going to do something like in Rust, you might use like no standard annotation to say like, I'm not going to bring the Rust standard library into this. Or you might say, you know what, I'm not even going to have any kind of like a post-implementation, we're just going to do direct syscalls and that's it. My platform is just like all we do. We don't bring in any kind of standard library. For the lower level language, it's literally just syscall. You could even write an assembly if you wanted to. And if you really, really wanted to, you don't even have to have an operating system under there. You could just say, I'm writing a unikernel, something like that. I'm writing my own operating system, and Rock applications can run directly on that. So the point is that this is an abstraction that isn't prescriptive about how many layers have to be underneath it. You can sort of judge for yourself what you want to do based on what makes sense for your use case. So in other words, the Rock platform can be as high level or low level as you choose. The application is written in the higher level language where memory management is automatic and stuff. Like Rock is not a systems programming language. And that's kind of what this talk is about, is the idea of high level isn't automatically bad, low level isn't automatically good, but the more that you understand about low level, the better you can potentially make your software. Okay, so let's talk about like sort of different levels for different needs, depending on like what you're doing. So here's 3 functions: parse CLI args, handle response, and infer content type. These are 3 things that can come up in a static HTTP server. So parse CLI args would be a function that's like, you might want to configure it, set different options around like, caching behavior and stuff like that. Handle response will be the thing that's actually doing the I/O. And then infer content type is basically like in a static HTTP server, you're usually looking at the file extension to infer what content type to send to the browser. So parsing command line arguments, really low performance impact. If you do this in a high level language and it's like, 200% less efficient than it could be, like in other words, it could be like maybe 1/4 as much runtime, probably not going to be a big difference. Probably not going to be noticeable. I mean, really, the thing that's going to be noticeable is the response time. Like that's the whole problem I had. I was not having any problem with like, man, it really takes like 8 milliseconds instead of 6 milliseconds to start up. Like, I don't really care about that. And in fact, the Node.js one actually did take noticeably longer to start up. But again, for my user experience, I didn't really care because I'm only starting up once and I'm just leaving it running for like half an hour while I'm working on the website. So that just was not a big impact on my experience. And then again, the inferring the content type, this is just a pure function that just like looks at the end of a string and then returns another string that's, both of them are static. So really not a big deal. But this handle response part, this is really important. And so if I'm building something in a high level language, understanding the low level, like this is the part that could potentially be slow. And even ideally going as far as to know, this can just be 2 syscalls. And if it's more than that, then that's potentially why it's being slow and unpleasant to use. So I want to talk about this idea of sort of hybrid level programming of like working simultaneously in the same project in like a high level way and a low level way in practice. So I'm going to give 3 examples here. So one is Zoom, another is Zed, and the third one does not start with a Z, it's Simple Note. These are 3 programs that I've used all the time in my life, and they both do a mix of high level and in some cases more or less low level programming. I want to talk about sort of what's nice and not so nice about them. So let's start with Zoom. So recently, a soon-to-be coworker of mine tweeted about this screenshot of Zoom and kind of asked the question, "Why is this so popular?" Look at this stuff. There's all of these like pop-ups about like, "Hey, look, new feature, another feature," and then look, you want the AI companion in your video chat? Like, yeah, why is it this way? And like, who actually wants this? This is clearly not a delightful user experience. I don't look at this and think this is software I can love. This is software for humans. This seems like mistakes were made. Well, I remember back in 2013 when I first heard about Zoom, and the pitch, for those who have not used video chat back in 2013, it was not as reliable as it is today. There was a whole lot of like latency issues and people's volume levels not being right. And then there was a whole lot of, wait, hang on, can you say that again? Or like, hey, dude, wait, you turned into a robot. Sorry, can you, there was a lot of like weirdness. And the pitch that I heard for Zoom from one of my coworkers who was like, I think we should use this, was it's video conferencing and it works. That was the pitch. He was like, it actually works. And I was like, sold. That sounds amazing. Are you serious? Let's get on that right away. And I've talked to other people who remember this kind of the same thing. It's like, that's why Zoom got really popular. It was video conferencing that actually worked. This is not that. This is not any part of that pitch. Like all of this UI stuff that's going on here, at the end of the day, it's like, I don't know, I just hit X on all those things and I move on with my life. I put up with this in order to get the benefit of it just works. And to be fair, today there's a lot more video conferencing software that works a lot better than 10 years ago. Now, worth noting that all of this stuff here that's not delightful, this is all done in a high-level way, I'm assuming. I mean, I don't know for sure. I don't know what Zoom, they have a proprietary code base. I can't look at their code and figure out exactly, how they did all this. But all the stuff that is not delightful here happens to be high-level, and all the stuff that I'm here for is low-level. like getting the latency to work and getting all of the synchronizing everything well, like matching the volume levels in real time and stuff like that. All of that requires really low-level programming, because if you don't do low-level programming, it's going to be too slow. There's going to be too much latency, and that's going to result in a non-delightful video call experience. Video is a good example of something that's extremely latency sensitive for the user experience. And if you're not going down really as low level as you can, you're probably going to be having a really hard time creating a really delightful user experience. So this is an example of a company where they made a product that, at least back in 2013, before they added all these pop-ups and stuff, was really delightful and really made us happier than all the alternatives that were available because of the low-level programming they did. And then later on, it was kind of the high-level programming. Unfortunately, they kind of messed things up. So why is Zoom's low-level software lovable when its high-level software is frustrating? Like, how could this be? It's the same product. It's the same team of people. Worth noting that this kind of gets into one of the dynamics that we see in our industry a lot, which is, I'm guessing the parts are probably made by different people. They probably have different teams working on the UI portion of things from the really low-level stuff. And I think this, unfortunately, is a split that often leads software to be less delightful than it could be. Like, having different people working, it's like, well, you have high-level people over here, and you have the low-level people over here, and they're going to do the stuff that makes the product really delightful, and they're going to do whatever. Like, I think if you had more people who were capable of doing both, and more people who understood both, or maybe not, obviously you're always going to have some degree of specialization. You're going to have some people who have more expertise than others in a particular area. But I think having more people have more of an understanding of these things would be helpful in creating more cohesive products that hopefully don't get ruined over time, or at least are less likely to. Now, I don't know what high-level language they're using. I'm guessing something like Swift on macOS. I don't know what low-level language they're doing, something like C++. But for the purposes of this talk, I don't actually think the language itself is that important. I say this as somebody who's making a programming language. Obviously, I think languages have a lot of benefits and a lot of potential here. But in this particular case, I don't think the language is the actual issue. I mean, I think nicer languages can help us make lovable software, but they're neither sufficient nor required. Like, you can make lovable software in C++, it's true. And you can, help people make even nicer languages with nicer languages than C++. But it's not like those are required. It's not like that's the only way to do it. These are just tools that can help us make lovable software. Hopefully, ideally. In other words, languages don't fix this, but they don't really cause it either. This is something separate from language. Okay, I want to talk about Zed real quick. So, full disclosure, I like Zed so much. It's an editor. It's a code editor that I'm joining the company in about a month. So, big fan, obviously. But Zed has a really interesting story. So, the backstory of Zed is, does anyone here remember the Atom text editor? Show of hands. Okay. Oh, yeah. Wow. Almost everybody. Cool. So, I used to use Atom back in the day. It was originally designed to be something like a hackable, graphical user interface editor. So something like Emacs in spirit, but with a full GUI instead of being based in the terminal, stuff like that. So this was created at GitHub, and later on, its original requirements were, as I found out from talking to the founder of Zed, who worked on the Atom team, one of the earliest people working on the Atom project. The original requirements, which he did mention, did not come from him, but rather from his boss at GitHub, who was really excited about this project. It had two requirements, one of which I think is more reasonable than the other one. The first one was extremely hackable. Okay, fair enough. And the other requirement was it has to be built using web technologies. All right. So this led to a spin-off project from Atom called Electron. Has anyone heard of Electron? I heard a groan. Yeah, so you get it, it's an atom, and you spin off the electron. Okay, so anyway, so Electron is the result of this design requirement of this editor shall be built using web technologies. So Electron is web technologies, and the native GUI apps built on web technologies. So one of the things that it's most famous for, or infamous for, is you use, let's say, a music player that's built on Electron. And that is an entire browser running, you have a separate browser for each one of these apps. Also, funny things like there's apparently an Xbox 360 controller driver code in there because, that's just part of the browser. And so you just get that and all the other stuff. I had that diagram of layers earlier. I don't even know how many layers we're talking about at this point. There's just a lot of stuff in a browser that that goes into making one, almost none of which is actually required for this particular use case. But it's familiar to web developers and so on and so forth. And so, Electron's been quite popular as a choice. So if we were to sort of, ignoring the whole number of layers in the browser itself and talk about what are the layers involved in Electron, So the operating system at the bottom. Then, of course, there's a JavaScript interpreter on top of that. And then there's all the browser APIs on top of that, ignoring how many stuff is going into those APIs. And then finally, at the very top of that, you have the actual rendering abstraction for actually like putting pixels on the screen and organizing things like that, which usually is something different. This is where you get like React.js and stuff like that, because as it turns out, the browser APIs turn out to not be people's favorite things for making complex applications like a code editor. Okay. Now, Zed, again, founded by some of the same people who worked on Atom back in the day and had that requirement. According to Nathan Sobo, who was the founder of Zed, he was kind of skeptical that the performance was going to be there for the web technologies requirement from the get-go, but that was the requirement, so he went with it. But now, basically, Zed is sort of an opportunity for them to say, like, hey, let's not have any requirements other than just making the best possible code editor that we can, the most lovable editor that we can. Now what can we do? So I talked with Nathan on my podcast, Software Unscripted, and I want to just play a very little 1 minute clip of something that he said, because I think it's very relevant to all the things we're talking about in this talk, but also at this conference.
But then I remember a lot of the learning at that point was just like, what is it like to actually just build a freaking Mac app? And I don't want to do Xcode. I don't want to figure this out. Like, in a Mac app, in main, what happens? And I didn't want to use any abstraction layers or whatever. I just was like, I want to learn exactly what these Mac APIs are, either find bindings to them or write bindings to them, figure all that out. That was kind of when some of the early event loop stuff got figured out. Yeah, just kind of stumbling through, like, how do we actually build a native app in Rust?
So I want to, microphone again. Are we back? All right, cool. Yeah, so I want to highlight a couple things that he's saying there. So one is that essentially he's like, hey, how can I just get rid of all of these layers? I don't want to have any of this stuff in my stack anymore. I want to go all the way down to the lowest level APIs that the operating system will expose. In this case, on Mac, because he was using a Mac. And like, how can I make that be my primitives and then build the application that I want to build on top of that? And this is, again, like, the idea is he wants to make the most delightful thing that he can. He wants to make something that's not bloated, that runs as fast as possible. Because when you're in a code editor, that's really important to the user experience. Like, waiting and feeling latency and stuff is really frustrating in a code editor the same way that it's really frustrating in video conferencing. So how did he do that? The answer wasn't like, well, I think maybe I should start with all this and then add some more stuff on top. It was the opposite. He was like, no, let's go all the way down to the bottom and just get rid of all this stuff that is in the way of the user experience and then figure out what we can build from there. So he ended up creating a new abstraction called GPUI, and we'll talk about the benefits of like why he actually made this abstraction, or the team did. And basically this is like, start with the operating system and then boom, we just have the rendering abstraction right on top of that with nothing in between. Now, the reason that they did make a rendering abstraction is, they're working on this product, Zed. It's not just like they're making this abstraction for the sake of making an abstraction, but like they actually have designers using this. So at Zed, the company, like they have designers who are writing Rust coding in GPUI to like actually implement the user interface, hopefully as delightfully as possible. And I think this would be something that's like pretty difficult if they were trying to just say, hey, just make direct macOS API calls. Also, one of the goals of Zed is, of course, to run on multiple operating systems, not just macOS. And so having this abstraction lets them share code that is implemented once and then is going to work exactly the same way, hopefully, across the different operating systems. And then, so the only one layer below that is essentially what are the operating system specific rendering calls that you need to make on each of those different targets. But hopefully there's as little as possible in between the two. So the abstraction is getting them some value. In other words, like designers are able to actually write code to implement things. And also you get the cross-platform thing. But that's sort of the bare minimum. Like that's really all that you want out of the rendering abstraction. You don't certainly want to have an entire browser stack in between if you can get away with not having one from the end user's perspective. So again, I'm not talking about like high level is bad, high level is like, the enemy or anything like that, but rather that it needs to pay for itself. Like if you're going to be adding layers of abstraction, there needs to be a really high bar set for like, okay, what is the cost in terms of user experience and what's the benefit? And if the benefit's high enough, okay, absolutely, add a layer. But we shouldn't be doing this as casually as I think we have as an industry historically. Like the idea that this seemed like a reasonable thing to do, I think should be looked back on as a mistake at the outset. Like having the requirement in the first place of saying like, let's start out building an editor with this many layers mandatory seems like a mistake that hopefully in the future we could just say, no, actually we should start lower level than that from the get-go if we're trying to build something like a code editor. So, again, just to summarize this, like creating a faster abstraction than what they had before required creating one layer that was able to replace several layers. So they still had some abstraction, But the point was that they were able to eliminate all these intermediate layers, and that, of course, requires some low-level knowledge. Another thing I wanted to point out from that little snippet that I played of audio of Nathan talking about that was he didn't know how to do this stuff when he got into it. He learned it on the fly. He was like, the goal is I want to get rid of all the layers, and I don't know how to do that on macOS. I've never done this macOS stuff. He's like, how do I figure out how to do this? How do I figure out how to get rid of all these abstraction layers and just do that? And that's something we can all do. Like, even if we think of ourselves as high-level programmers, or we're, maybe at this conference, less so than at your average software development conference. But the point is that, if you know somebody who maybe thinks of themselves as like, I only do high-level programming, I like beyond this browser or beyond this set of abstractions that I'm used to, that's all dark magic that is very unfamiliar to me. Well, it doesn't have to be unfamiliar. I mean, you can do what Nathan did and say, like, I don't know what that is, but in order to build the product that I want, I'm just going to go learn it. I'm going to go figure out what these APIs are because there are documents out there. Other programmers do it all the time. I'm going to do it too because that's what's necessary to create the best experience I can for the people using this editor. So, as it happened, like Nathan chose Rust, but again, the lower level pieces can be done in a number of different languages. Shout out to Zig, C, C++. There's a lot of different ways you can do this stuff. The point, again, is not the language, but rather that, the idea of stripping away layers and figuring out how to go as low as necessary for especially the most performance critical parts of your system. You cannot do this in JavaScript alone. If you're like, we're going to do this is going to be a JavaScript project built only on web technologies, you can't make syscalls from JavaScript, not even a Node.js. Like, you have to do FFI to some other language if you want to do that stuff, which means that if you only know, higher level languages, at some point, if you do want to go lower level, you will end up needing to understand some other language. But honestly, there's fortunately a lot nicer languages to learn those things in, like Rust and Zig, than there were when I was coming up, and it was all C and C++, and that was about it. So worth noting that some languages are sort of better on their own at this like hybrid level thing. Like in Rust, for example, that Nathan chose, it's possible to do the low-level stuff and do direct syscalls staying in Rust, and then also have this higher-level stuff on top of that graphic designers can program in. Some languages like Rock are not designed to do both. They maybe have like a symbiotic relationship with a lower-level language. Also fine, but the point is that if you want to get into this lower-level stuff, you're probably going to have to learn a lower-level language at some point. Okay, and finally I want to talk about Simplenote. And Simplenote is essentially a little bit of a counterbalance against these previous things. So this is what Simplenote looks like. It's basically a note-taking app. I use it all the time, like every day, except that my phone bricked on my layover, so I don't actually have a working phone right now. But if I did have a working phone, I would have been taking notes in Simplenote probably already many times today. And basically, it's got this very simple UI. You've just got a list of notes. You can search them. You can write Markdown in them, and it automatically synchronizes to the cloud. A thing that I really appreciated about Simplenote was I had written some stuff on the plane on my phone in airplane mode, and then when I got to Heathrow and very briefly connected to the Wi-Fi before the phone bricked, when I got on my laptop later, it had actually synced all of the things that I'd written on the plane, which I was very happy about because I'd written quite a few things on the plane in there before the phone bricked, and I'd never even opened the app on the phone. So it really does a good job like doing the one thing and doing it really well. It's like simple, note-taking, great. It's like it doesn't support images that's fine. I don't need images. I just needed to let me take notes and synchronize them and do a really nice job at that. Now, as far as I know, based on a blog post that they wrote previously, they wrote Swift for the macOS client, which is what I primarily use when I'm not using it on a phone. And apparently they actually use Electron for the other clients, like on Windows and Linux, and like on mobile browsers, mobile phones, then it's something else. But that means like there is an actual browser in here on Windows and Linux. And I have used the actual app on Windows and Linux, and honestly, I didn't notice. Like if they hadn't told me it was Electron, I wouldn't have necessarily realized that. I mean, maybe if I have looked at the like resource usage, I might have noticed that. But honestly, it felt fine. I didn't realize that it was an Electron app in this particular case. So, and I've used the lower level, relatively speaking, Swift app and the higher level Electron app. And given that I couldn't notice the difference, again, I'm not going to look at them and say, hey, you made a bad choice because this was really bad technology. I could have had the same user experience with, instead of having 60 gigabytes of RAM free, I could have had 61 gigabytes of RAM free because you used Swift instead of Electron. But at the end of the day, like I'm not really noticing a difference there. It just didn't make a big difference in my life. So I wouldn't be as critical of the choice of Electron in this particular case based on my user experience as I would be in the case of something like Atom or Visual Studio Code, Where if I look at that side by side with Z, I can immediately tell a difference. It's just like Z feels way noticeably snappier. So not saying that, you can't create delightful software using things that I consider to be over-engineering, bloated, things like that. You absolutely can. But that's not to say that the reverse is also true. It's not like, therefore Electron's always a fine choice, just because in this particular case, it happened to be, unnoticeably different. Now, what I noticed if they went all Electron, this is actually an interesting question I wondered myself, because another thing that's different about my Mac versus the Linux and Windows environments that I'm using on is it has a different processor. It runs faster in general. And so maybe I would notice more the like relative lagginess on the Mac than I would on the others. I'm not sure. But at any rate, certainly for the current user experience, I had no idea that it was Electron until I read about it in their blog post. Now, to be fair, I've also personally worked on apps like at work that felt really sluggish, and they weren't using Electron, but they were using more layers than in retrospect I think was necessary. But I remember having conversations with people about why it was sluggish, and removing a layer really never came up in those conversations. That was just considered like kind of a bridge too far. Like in particular, I remember one app that we were really struggling to get performance enough. It was running in the browser, but when I remember back like to the requirements of that, the people who were using that app in the browser all worked at the same company. And in fact, we decided, we got further and further into performance optimizing it. We were like, let's just mandate that everyone uses Chrome so we can just optimize this for one, JIT in Chrome and not have to think about, Firefox and Safari and the others. We could have just said, let's make this a native app, but that didn't even come up. Nobody even discussed that. It was just like, well, this is obviously we're starting with the assumption this has to run in the browser. And we never really questioned that and say like, well, could we strip out some of these layers that are making it really, really hard to optimize this? Didn't even come up. Never really seriously considered. And this is something that I've seen at multiple jobs, is like there's this kind of trend of when we talk about, hey, how do we make the best user experience? Oftentimes we start with, as Adam did, this presumption of like, we will start with this many layers and now let's talk about how to make the best user experience. As opposed to, in my mind, I think what we should be talking about is more, how do we make the best user experience? What do we anticipate being the like biggest barriers to that delightful user experience? And can we make the high level parts be stuff that's away from that? Can we make the high level parts be things that are not going to be distracting from the user experience? Can we make thin abstractions like GPUI that are not going to degrade user experience, but still let us do things like having designers write code in the product? These things can be done, but I think it needs a cultural mindset that will permit that. So I think another part of this is just that, if I'm honest, like the team didn't feel capable of taking out a layer. Like when I was at that job, and this is also a common thing I've seen in other jobs, if I had brought up, let's say, I had time traveled back and had this mindset and I said, hey, why don't we do a native, client? I think one of the things that they would have said is like, yeah, but like nobody here knows how to write, Objective-C back then or Swift today to make a Mac client or something like that. So, we just can't do that. And this is the piece where I think there is some knowledge that has to happen if we want to be able to create these good experiences. It's not just that you necessarily need to learn a lower level language, but also maybe some lower level APIs. But the cool thing is, like, we're at this conference, software you can love. If you want to make software you can love, I think this is a really valuable thing to learn, is like how to do that. Or on the flip side, if you're only familiar with low level stuff, there's definitely some like design concepts and things like that at a high level that you can also use to make software more lovable. The point of this talk, and the reason this talk is called hybrid level programming, is not to say you should do low level programming or you should do high level programming, but rather that if you want to build the best experiences for people and the most lovable software, I think it's worth getting good at both. Okay. Briefly, I want to talk about some hybrid solutions to technical problems. So this is a brief shout out to Brian Carroll, who's in the audience. So at a previous job, we were transitioning from one language to another. This is on like a web app. On the server side, we had Ruby, and we were transitioning to a different language. And we talked about, okay, how do we introduce this incrementally? We talked about, well, we could do inter-process communication and have the other language running in a separate process, and then have Ruby talk to that over IPC. We also talked about just making a separate server, which has even more overhead than IPC. Somehow, we never really considered what Brian ended up going with and sort of introducing was like, hey, what if we just did like, they both have CFFI. What if we just like called the functions across the thing and didn't do any of that stuff? This was actually a technical problem that manifested in the organization as like, hey, we can't find a project small enough to make like granular project progress on this. It was like, hey, anytime we want to try doing something in this new language we're trying to move towards, we have to like spin up a whole other server or spin up a separate process and get like logging and all this other stuff like going between the two. it wasn't until somebody joined who actually had the skills to be like, hey, could we do this, because he actually knew how to do it, that was even an option that was discussed. So again, this is not really necessarily about, end user delight. This is really about like behind the scenes, which is kind of a smaller part of the talk. But at the end of the day, like there's more than just end user delight motivating this type of stuff. Sometimes you have technical problems where the only way you can possibly consider one of these options that might be the best option of all is if somebody on the team actually has some knowledge of low-level stuff. So one more reason that I think it's worth, knowing both. Okay, so to summarize some of the reasons that sort of hybrid isn't considered as often in practice or in industry as I wish it were. One is the team doesn't feel capable. Another is cultural norms. So someone says like, hey, I am a front-end developer. That's what I do. So if it's not front-end development, I don't do it. This is a mindset that I once had, and I think it's just harmful. Like, I think we should have less identity about what type of developer we are and just rather think about like, hey, I'm a programmer. I like to make lovable software for people. If there's a way that I could make more lovable software, maybe I should consider learning that way, because then I could make more lovable software, and that's it. And not have so much identity around like, what camp we're in, but rather just about like, hey, we're in the camp of like, we like to make nice things for people. I think that would be healthier and would also make it a little bit easier to like break down some of these barriers. Another one, honestly, is that the ergonomics when sort of mixing high level and low level, depending on the scenario, can be pretty painful. Like definitely I would not want to have like a big C++ code base where I'm like, well, we're doing low level stuff and we're also doing high level stuff. Now, granted, I've had personally bad experiences with C++ in the past, but I'm sure there's some people out there who are a fan of C++, and that's fair enough. But certainly the question of like, how do the ergonomics feel to the individual programmer doing it is always going to be a factor in like how much people are willing to consider these things. Build reproducibility is a big one there. Like definitely like lower level languages historically have had a lot of problems with like, it builds on my machine, but it won't build on this other machine, which has not been as much of a problem with higher level language, like missing dilibs being another one or the wrong version. Also tricky type mismatches at the boundary. So like if you're doing that FFI strategy, like on the one hand, it can have some really nice technical benefits, but a thing that can be hard is having like, okay, I want to like call from this language to this other language. If I don't get the ABI right, then the errors that I get can be very, very painful compared to just like, making a mistake in a like within the same language function call. So how can we make those things easier and make it easier for people to get into doing both types of programming? One is like nicer language support for low level. Hey, Zig, like just having nicer lower level languages, definitely a plus. I think having some modernized learning materials, like the idea of like, hey, let's get into low level programming. Have you read K and R? Like, all right, come on, like we can have things that are more like directly applicable to what types of problems programmers are facing today. And I think that kind of goes hand in hand with the nicer languages. Better build systems. So like definitely, again, Zig and Rust are like doing good things in terms of making it easier to just have a reproducible build that doesn't require lots of like make file, this kind of stuff. Also, boundary type generators, I think, is really like a promising way to help glue two languages together. So in Rock, we have one built in called Rock Glue. So you can just say like, I want to have my platform in Rust or my platform in Zig or whatever. And you can run Rock Glue and then give it a little glue spec that basically is able to say, knowing your exact Rock application, your exact Rock platform, I'm going to generate all of the bindings for you that will go between, Rock and Zig or Rock and Rust or whatever. Obviously, somebody has to like write that and get it right. But the point is that then everybody else can just reuse that, and you can have like hopefully one really solid way to generate that boundary and get type checking on both sides. And then it can feel a lot more like making a function call within your own language as opposed to trying to get that right manually, which we found is really difficult. And then finally, honestly, this might seem like kind of unrelated to the others, but less reliance on dynamic libraries. Like these seem to be a really big common source of like pain and lost ergonomics when trying to do like a mix of high and low level programming. I remember very early on, the first time I worked at a company that did Ruby, a really common experience was I would try to install all my Ruby packages and they would all work except for one, which would give some inscrutable linker error saying like, I cannot find whatever, lib something. And I'd be like, help, what do I do? I'm trying to program Ruby and there's lib something and I don't know what this means. Now, part of that is, hey, maybe we should like teach people more about, like what's actually happening there and like how dynamic libraries work. But another part of this is like, why is this happening at all? I mean, we don't need to live in a world where we're doing that. Like memory, we have a lot more memory now than we used to back when having dynamic libraries all the time was like a really critical thing for performance. We can just do more like building with static libraries and things like that, and not use dynamic libraries unless there's a very specific, compelling reason to. Okay, if you're trying to wonder like, hey, how can I get into low-level programming? Like while being a high-level programmer, like, Nathan was founding a company, and he could just be like, hey, I'm just going to do this because this is the way that I'm going to, like learn how to build the products I want to build. That is one option. You can just say like, hey, I'm just going to go straight to the OS from like whatever I'm used to doing before. I used to be doing JavaScript, and now I'm just going to learn Zig or Rust or whatever and just go straight to syscalls. That is an option. Maybe for some people that's not as good of an option. So if you're feeling that's like maybe a bridge too far to start off with, I would recommend just try subtracting a layer. Wherever you are, how many layers you're building on, ask yourself the question, what would it mean to subtract one of these layers? And just see if I can try building on that. Just try to go one layer down and then repeat. Do that again. After you're used to like comfortable working with one less layer than you were, maybe you thought of yourself as like a Rails programmer, and now you can say, you know what, I'm just going to use raw Ruby. And then again, you get comfortable doing that, and you say, okay, how can I go one level below that? And how can I go one level below that? And eventually you'll end up with the operating system. And then if you want to keep going, you can end up with the kernel and stuff like that. But, up to you how you want to do that. Definitely recommend computerenhance.com as a learning resource. This is mostly focused on performance. Like the title of the course is Performance Aware Programming. Casey Muratori does it. I love this. This is like, I've been watching it. I've been a happy customer of theirs for a while. And this is the stuff that I wish that someone had sort of told me about and like helped me out with when I was initially getting into like getting lower level stuff. It's like really approachable and does a really good job going into a lot of detail, like what's actually going on with the CPU and all the layers above it. Another way you can potentially get into low level stuff is with Rock. So you can start off as a Rock application developer, and Rock is a nice high level language, automatic memory management, all that stuff. But as we saw previously, like on the platform side, you can go all the way down to the operating system or even replace the operating system with a platform. So it can be as high level or low level as you choose. And I think you can totally do in Rock, and that I strongly encourage Rock developers to do if you want to do this, is start out doing application development and say like, this feels like a Python or a Ruby or something like that, but with type checking and better performance and stuff like that. And then just be like, you know what? I want to get into platform development. Like I'm used to building on top of this thing, and like maybe there's some particular piece that's like not fast enough, and you're like, I want to just add a new primitive to this platform that doesn't exist, that goes straight to the operating system and just gives me access to that in my application. You can totally do that. You know, if you want, you can try like forking and customizing your platform just for the fun of it, just as a learning experience. Like this is something that's totally accessible in Rock, and hopefully this can be a way that Rock can help people get into lower level development in addition to their high level development and become more on the hybrid side of things. So to sum everything up I've been talking about here, expanding your programming toolbox to include both high level as well as low level programming increases your possibility space overall for creating software you can love. Thank you.
Thank you. Thank you very much, Richard. So please come back to the chair so we can do the closing Q&A. So thank you very much. Since I went a little bit late, we're going to make it short. But I wanted to ask you one big question. So you are not only a speaker, but also I think you mentioned that also during your talk a little bit. You've been to different companies where you've introduced the company to a new technology, right? Can you say that a little bit about that?
Oh, sure. I mean, well, so 2 companies ago at No Rate Inc., I worked, when I joined the company, I was there for 9 years. When I joined, it was all like Ruby on the back end and JavaScript on the front end. And so I initially got into the Elm programming language, which is a functional programming language that compiles the JavaScript. So one more layer, but all actually, in comparison to JavaScript, you end up with, in some cases, fewer layers because Elm replaces multiple things that people use user space libraries for in JavaScript. But basically, introduced it and I maybe the question is like, how do we introduce that? How do we successfully?
I guess my question is, given your experience, okay, so you mentioned a little bit of what you did in the past. So given your experience doing this kind of work, I was wondering, do you see companies, just like over time, they basically had to adopt like agile practices with varying degrees of success, of course. But do you see companies waking up to the idea of explicitly forming their developers to be able to do both high level and low level, like hiring consultants to give the kind of training similar to what they do with Agile, for example, or not? Maybe they won't.
So I would say I haven't seen it, but I would like to see it. I think it's something where, I talked about a couple examples in this talk of like companies where basically like the reason their product is nicer than their competitor's product is that they invested in low level in addition to high level. And it feels like not that many companies have necessarily realized that that's what's going on there. it seems like maybe there's like, I don't know, Zoom for some reason. It's really popular. I don't know why. And you know, Zed is like, it's sort of an up and coming editor. It's, you know, getting a lot of traction, but like not nearly as much traction as like the existing Electron stuff like Visual Studio Code. But at the end of the day, I think if Zed ends up being extremely successful and like, you know, taking over that space, it will be because of this. So maybe if enough of these examples start coming up, then companies will look at it and say like, oh, hey, hang on, wait, I just realized there's a trend here. There's a commonality here, but so far I haven't seen it yet.
I see. So who knows? Maybe that could be an interesting business idea for some people watching the stream or in the audience.
Could be.
Okay, so I'll accept one question for the audience. Is there anybody with a question? Raise your hand. If so, and if so, then shout it. Yeah, here's one. Please shout it. I'll repeat it. Okay, so the question is you mentioned building an editor for Rock in the past. The question is Zed going to be that editor?
Well, Zed is its own thing. I mean, Zed and Rock are separate. I'm not actually like currently planning on doing any Rock at Zed. If it happens, it happens. But like in my mind, I'm thinking about it like I'm really excited about Zed as a independent project, like totally separately from Rock stuff. And then separately, we have our own goals on Rock. So I'm not conflating the two. It's more just like I'm excited about this project for different reasons that I'm excited about this other project. If there ends up being some blending of the two, cool. But like, I'm not like aiming for that.
Okay, perfect. So please give it up for Richard. Thank you.